Alright guys, today talking about elimination. Guys, that's where you can add or subtract equations to eliminate a variable. Okay, so in these problems, you're looking for variables that have the same term or opposite terms. Like in example 1 here, we have these two equations. I'm going to rewrite them just so I can show my work here. We have these two equations, and we have a negative 6x and a positive 6x. We have a variable that has opposite terms. Okay, that is useful because if we add these two equations together, something interesting happens if we're adding the two equations together here. Negative 6x plus 6x, well, that's 0. Negative 6 plus 6 is 0. Eliminating those x's. Okay, eliminating the x's. 7y plus negative 3, that would be a 7 minus 3. So that would be a plus 4y equals negative 16 plus 0, negative 16. So eliminating the variable x leaves you an equation with just the variable y. You can solve that equation, as I just did there, by dividing by 4, and you've solved the system for one variable. Okay. After you solve the system for one variable, you have to solve for the other. So at this point, that's when you take this variable and you're going to plug it in to one of the first two equations. I'm going to go with the bottom one. It doesn't matter at all which one you plug it into, but I want to plug it into this bottom one. So I'm going to plug in the variable y, which we know is negative 4. And I'm going to solve now for x. So this is 6x minus negative 3 times negative 4. That's a plus 12 equals 0. Subtract 12. And dividing by 6. We've got x equals negative 2. So this system of equations, the solution to it is the ordered pair negative 2, negative 4. And again, any solution to a system, because we write it as an ordered pair, writing it as a point, xy. Okay, so that's your solution to that first system. All right. So example 2 is a little different. Example 2 here, we have terms that are the same. We have these negative 2y's in both equations. They're the same. And so what you do when you have equations that are the same, you subtract, or variables that are the same, you subtract these two equations. So let's think here. We've got 6x minus negative 7x. So that'd be positive, double negatives make a plus, so positive 13x. Here you have negative 2y minus negative 2. Again, the double negatives minus negative 2, that's really going to become a plus 2. So negative 2y plus 2y cancels. It's 0. Okay, and that's going to be equal to 8 minus 8. Well, 8 minus 8 is 0. So here we have 13x equals 0. And we can solve that equation. 0 divided by 13, guys, is 0. So this equation, we eliminated the y's first and solved for x. Okay. In this example, I'll go back and I'm going to plug in that x variable to one of the original equations. I'll plug it into the top one here. that's 6x is 0 minus 2y equals 8. 6 times 0, guys, is just 0. Divide by -2. And we got y equals -4. So our solution here is 0. It's my xy ordered pair, 0, comma, -4. So that's the solution to number 2. All right. All right, sometimes you have a problem like number 3, where we don't have same terms, we don't have opposite terms, and we need to multiply one of the equations by a number to create opposites. Because when I look here, I see that if I multiplied this bottom equation by 2, that -8y would become a -16y, and my y's would have the same terms. So I'm going to do that. Guys, I'm not going to change that top equation, so let me rewrite that. But that bottom equation, I'm going to multiply every term by 2. 2 times -5, that's -10x. 2 times -8, that's -16y. 2 times -1, -2. So multiplying everything by the 2 there. And again, the reason I did that, and I recognize, guys, 16 and 8, well, I could make that 8 into 16 by multiplying by 2. Okay? Because we got the same term there, so we're going to subtract our equations. -9x minus -9, that's positive 1x. Double negative, so -16, that becomes plus 16y, so those cancel to 0. Equals -5 minus -2, that becomes plus 2. So here we've got x equals -3. Okay. And again, needing to go back and plug into one of the originals, so I'll plug into the bottom one here. -5, I'm substituting -3 for x. So that's a positive 15. Subtracting 15, -8y equals -16. Divide by -8, and you're going to get y equals, it's a positive 2. So your solution, your ordered pair, -3, positive 2. Okay. So there's 3 elimination examples. One more. The most complicated is when you can't immediately make things opposite or same terms. Like this 2, I can't multiply it by something to make it 9. This 4, I can't multiply by something to make a 5. Okay, and so in this type of problem, let me erase that there. In this type of problem, what you end up doing is multiplying both equations by a number. Okay, typically you can multiply that, if I want to eliminate my x's, well, what if I multiplied the top by 4? That would give me a 20x. I'll tell you why I'm picking that 4 here in just a moment. 36y, and 4 by 19 is, I need a calculator for. I should know this off the top of my head, 76. Gee. All right, and so the reason I picked 4, guys, is because I know, well, now if I take the bottom and multiply by 5, well, that's going to give me a -20x on the bottom one, and a -10y, and a positive 80, is that right? 5 by 16? Yep. Okay, and we can add the equations together. The x's will cancel. We'll get 26y equals 156. It's just 156 divided by 26. Which is 6. So there we've solved for y. And we're going to go back to one of the original equations. I'll go to that bottom one there. And I'm substituting in y. So it's negative 4x minus 12 equals 16. Add 12. That's negative 4x equals what, 28? We got to divide by negative 4. And we've got x equals negative 7. So the solution here, guys, the xy ordered pair is negative 7, comma 6. Okay. So guys, there's four different examples of elimination. All kind of following that same elimination process, okay? Just different degrees of difficulty. So, guys, video was a little longer. We got 2 homework problems, guys. Make sure you get those done this afternoon, and have a great day.